Hey, everybody. Dave Lindberg, THD Podcast again. Today, we have a special guest all the way from Guangzhou. Normally, that's pretty close for me, being based in Hong Kong. But this year, 30 miles seems like an eternity. So, hey, Philip, nice to have you here. And also, Simon's joining in from Japan. And today, we want to talk about air motion transfer or air motion transducers. So Philip, Transformer, yeah, great. Please tell us more about this exciting technology.
Well, thanks for having me, David and Simon, DB Technologies. Appreciate it. It's good to see you again. Hopefully we can see with one another face-to-face after this curious times are over. An air motion transformer, also known as an AMT, or what other people call it, is a folded ribbon, is really an old technology created by Dr. Oscar Heil early in the 60s and 70s. He created this technology. The patents have expired in the early 80s, and some believers of Dr. Oscar Heil continued on the momentum of the coattails that he created with this incredible technology. Now, it's important to know that an AMT is not a ribbon. A planar is not a ribbon. A ribbon tweeter is an aluminum foil that is suspended on a magnetic, in a magnetic motor structure, and it moves according to the frequency. A ribbon is different than an AMT. A planar is a foil. Is a two-piece aluminum polyamide. It's a polyamide with aluminum trace that is CVD, that is chemical vapor deposition onto the polyamide to create that coil. And then behind the planar is a series of magnets that makes that planar go back and forth.
So
Philip, is
just
an air motion transfer.
Let me ask a question. So that's a substrate that's got a plating technology. So it uses like a chemical vapor deposition to deposit like metal traces, almost like printing a circuit board, sort of. Is that an idea?
Yes. That's one way to impregnate the polyamide, the aluminum with the aluminum coil. Another way is, which is the more cost-efficient way, is to get your polyamide, which is right around 12 microns thick, and cover the entire sheet of the polyamide with aluminum. And so the supplier, in our case, Japan, will send the polyamide roll to the supplier, and the supplier will either etch it by chemical or laser etch it.
Right.
Those are the two ways to create the actual pattern on the polyamide or on the capton. That's correct.
Okay. Yes. Very cool.
And then
very cool.
The pattern is created. Every company has their secret. We have our process to fold the actual diaphragm, so that the diaphragm looks like this before we insert it into the motor structure.
Wow.
Okay, so it starts on a foil on a big sheet, comes in 100-meter foils, and then it's processed to create the actual coil, and then we fold it in-house to put it into a diaphragm and slide it into the motor structure. So we'll take the actual diaphragm that looks like this.
Yeah.
Like this. We'll fold it into a jig, okay, and then we will slide it into a motor structure, so it looks like this.
Cool. All right. No, it's. I think in general, like I'm just gonna say the whole concept of the coding technology is very interesting, and I know there's some debate between additive versus subtractive processes. And what I mean by that is the concept of chemical or laser etching. Have you seen? I know that Kodak and some people have some coatings where they can do additive only and minimize the waste. Have you seen that out of Japan yet?
Yes, and that's called sputtering. And when they sputter the polyimide or the substrate, they sputter it onto the substrate, and that minimizes the loss. But it is not as tight of a radius. It's very difficult to keep the sputter in a very tight radius around each bend.
Right.
On a larger surface area, sputtering works perfectly. But for traces where we're talking about 15 microns in thickness and not more than 20 microns in width, sputtering is too heavy.
Right. Right. I know in like similar in like ITO film, so indium tin oxide film for touch sensors. So I think that the minimum tolerance, even the like
Yes.
what's it called, Fujifilm, they were only able to get to like I think 4 micrometer traces with accuracy on an additive process. So I can imagine that etching is kind of the way to go just to be accurate.
Well, the etching is a more of a utilitarian approach, and it works well for our application. But etching is too brutal of a process for touchscreen. It does not make sense.
Right.
So doing the additive, as you're mentioning, makes sense for large quantity touchscreens. Yes.
All right.
Absolutely.
Cool. So I guess like the foundation of the technology or this little film and can you show it how it works? Can we see like how we add energy to this to create a transducer to make some noise?
Yes. The Simon, are you still with us?
I'm still here. Yeah.
Okay, cool. Good to see you, Simon. The Jimmy Lila. A signal for a speaker is introduced to the speaker. So you have your loudspeaker that in zero position, you have this voice coil that's sitting in between the magnetic forces between the pole piece and the top plate. And when you add energy, it causes the cone to travel forward. And because of the natural suspension of the surround and the spider, it brings back the coil to zero position. So there was a lot of energy that takes place to cause the driver to go back and forth. Well, the same idea for a dome is that the dome has to sit in a magnetic field, must sit in a magnetic field. And so you put energy into, you put amplification or voltage into the dome, and it causes it to go back and forth. But then the dome weighs about 4 times as much as the AMT. So an AMT, when you introduce an AMT to a voltage, right, you can see here that the AMT is actually moving back and forth. It's like an accordion. It's squeezing the air out and forward into the listener's position, minimizing the combing effect. The problem with the comb filtering is that when you have a dome firing into playing into the listener's face, you have the dome that's going forward, and the first reflection bounces off the console or bounces off the floor or bounces off the wall and then hits the listener's ear. So you have a comb filtering effect. Compared to an AMT, because it's so fast and so direct, you don't have the comb effect when you're sitting in front of the AMT at 1.5 meters away. If you're sitting further away, then you might have a comb filtering because of the reflection from the floor. But a AMT is the fastest way to get the sound from 2.5 kilohertz and above 2 years, the fastest way.
So the
an
AMT is for high frequency applications.
An air motion transformer is identified for crossover point is typically 2.5 kilohertz, 2.4 kilohertz, and it goes past Scooby-Doo, goes to 21, 25K, depending upon the type of materials used in the manufacturing process of the substrate. Yes, sir.
And is it set up as a bipolar, or do you get radiation from both sides, or do you chamber one side?
Great point, Simon. Leave it to Simon to come up with a question like that. By nature, AMT, you could get what she is a good deal. By nature, an AMT is a dipole design. Okay, not by design, by nature, because the coil is printed on one surface area. Okay, unlike facing the back of the rear to the back of the room and forth of the room for surround sound applications, a ribbon or an AMT by design is a dipole, but because the sensitivity of the dipole is so delicate, you have to cover the back of the AMT with a felt to prevent the back wave of the woofer reflection into the AMT, causing it to distort, or you have to can it. Nice can, huh?
Yeah.
Or you put a can on the back to reduce, or in the box itself, you put an enclosure to minimize reflections of the woofer. Yes, sir.
So except for this problem where the woofer is going to basically just force the diaphragm of an AMT out to the limit, does anybody set it up on top of the speaker, for example, its own free space?
Yes, there is an aftermarket application for AMTs because it doesn't require a lot of voltage. The aftermarket, they use it as a super tweeter. So a super tweeter is beyond 20K. Most human beings can hear from really 30 hertz to bias 15 hertz, 16 hertz. And if you have super ears and you can hear grass grow, then you can go maybe 16.5 kilohertz. But very few humans can hear past 17 or 18K. Maybe a dog can, right? But you can hear the presence of high range frequencies. If you chop it off, you can hear the presence, that ambience, that feeling, that surround of high range, that harmonic. It's really a third order harmonic that you're hearing. Anything above 16.5, 17K is a second order, third order harmonic that you're hearing the presence of. Yes, sir. That's correct.
I've got another question too. Then it looked like by the construction you have like an accordion effect. So the actual diaphragm doesn't have a suspension like even the dome tweeter. They still have a suspension. So does that mean there isn't really a resonance, a fundamental resonance to it?
There is a resonance of an air motion transformer. It's below the crossover point, so if you shoot an impedance curve, it'll be pretty flat, but you'll get a little ripple right around 30, 40 hertz. You'll see a little ripple on just a little bit of step on the low end of the impedance when you do impedance curve, but it looks like a dead person. It really is. flat line when you do an impedance sweep on an AMT. You're not going to get this hump at all.
And so you touched on it, but just to clarify, the main advantage is you get this a big emission of high frequency sound that you struggle to get from a tweeter.
The most I lost you, Pitt's iPhone.
Sorry.
Yeah, it's okay.
Are we still live?
Yeah, we're still going.
So
Keep talking, Philip.
So we'll just add. Okay. All right. So a voice coil, the most important point of a dome, is that first dyne, that first energy to move forward, that very first dyne. And that creates, if you was to do an impulse response on a dome tweeter, if you was to do an impulse response on a dome tweeter, it would look like this at a macroscopic point of view, because it takes a lot of energy to make that dome go forward, whereas an AMT, that first impulse is forward and very tight, because it takes a lot less energy to make that impulse go forward. It's because it's so much faster. An AMT is so much faster. It's not trying to move air like a dome is trying to move air. It's really squeezing a very small travel, less than half a millimeter travel, less than 0.35 millimeter travel. It's squeezing air and causing it to go forward. So that's one of the reasons that it sounds so dynamic and so clear and so fast and immediate. However, there is a limitation of an AMT, and that is vertical and off-axis listening. So if you're using this for a near-field monitor, you can say that an AMT is the perfect tweeter for a near-field monitor, because you're not going to get a console bounce, you're not going to get a floor bounce. It's directly in your face and it's fast. Whereas a dome tweeter is going to allow you more vertical and more off-axis listening. It's more forgiving. Yes, sir.
Okay, cool.
I hope did that answer your question on.
Yeah. Certainly did.
All
And
right.
what kind of development time are you looking at for something like this? It's been going for, you mentioned somebody started it in the 70s.
Well, the development time that it takes to make an AMT is pretty solid. It's already mature. It's been mature in our factory for like 12 years now at Analog.
Okay.
It's a mature technology. However, sometimes we'll get customers that want to say, "Could I have something bigger?"
We're losing you, Philip. Hold on. Go.
Yes. An air motion transformer is the best possible high range frequency that you can want as in a bookshelf system or near field monitor, because there is no console bounce. There is no bounce reflection or combing filter from the walls, from boundary reinforcement or the console or the floor, because it's directly coming to you so fast and in your face. And that part of that has to do with the limited frequency, the limited horizontal and vertical response of a driver. If you was to map it out, an AMT will have a limited vertical field compared to a dome, which will go down a lot further. And on the side, an AMT will have more less of an off-axis listening compared to a dome, which has a wider off-axis listening. So a dome tweeter is more forgiving and allows you a wider sweet spot, but depending upon your application, AMT is really ideal for near field bookshelf speakers.
Okay, so yeah, like studio monitors would be a good category for this technology?
Studio monitors. Yes, sir. Studio
All right.
monitors is a perfect application for an air motion transformer.
Cool, very cool. All right, so you had a demo. You wanted to show us, like we talked about how tiny these things are and the really tight motion that happens in producing the audio. And you had a camera set up here so everybody could take a closer look. Shall we look at that now?
Yeah, let's come on now. Okay, if you can go to the camera now, and you can see that we're putting 9.4 volts into this at 33 hertz. Okay, don't do this at home, you're gonna fry it. But you can see that it's traveling, right? Okay, and then when we put more voltage into it, we're gonna increase it. What should we go again? There we go. Did you see it fry? You see the smoke? We just fried it, okay? Because we introduced 20 volts into it. And we'll replace it really quick with one more of our diaphragm. There we go. High frequency driver and designed for a crossover point of 2.4, 2.5 and above. We are happy to announce that True Analog, as far as I know, is the only company that can manufacture AMTs that have such a low crossover point at 2.4, 2.5 to past Scooby-Doo. Okay, let's, okay, Koima. All right, we can see that in a second here. Now,
add some power.
We don't really. Here, we add some power. Can you see it moving?
Yeah.
Isolda? You see it moving there? Okay. The we are strictly OEM, and so we the customers that know us. Otherwise, they'll be coming to Dave Lindbergh or to yourself or Simon for more questions and technical information, since we are really not open to the public. We're industry and trade only, so you can field the questions and then ask us in a format, or on your next coming visit we can take care of it. We're here just to give an explanation how an AMT works. An AMT is a lot of you'll see that the AMT is mounted on a motor structure. True Analog's technique is we use this as the motor structure. We use the actual motor. The top plate is a motor structure. So to prove that, you can see that this is magnetic. See, it's magnetic.
Wow.
Okay. Whereas other companies, they use a bezel. It is not magnetic. Okay, they use an aluminum faceplate trimming to mount it to the cabinet, whereas our technology enables you to mount it directly to the cabinet. You don't have the added expense of aluminum bezel to make it look pretty, or you can design a waveguide and rear mount it, okay, because that's one of the patented technologies of True Analog. Also, True Analog has a patent on a removable diaphragm. We're able to remove and do fuel replacements.
Ah, very cool, very cool.
So in the event that the customer has a disc tweeter, just order a new diaphragm and insert, and you're good.
Okay. So that's kind of what allows you to do the smoking demo, where You're able to
Yes.
easily burn one and then swap it out rather quickly. That's cool. That's
Yes.
cool.
But yeah, you would have to work to burn in the field because the crossover point is what will not enable any frequencies below 2.4 to enter it. But in case the guy was having too much fun and runs the amplifier into DC, then and fries it, then yes, you wouldn't have to replace the entire AMT, just the diaphragm.
All right.
So that's
So just in general to cap it up here, it sounds like near field is the heavy application for this technology, and it sounds like it's something very well specialized.
Hello.
Beyond near, is there headphone or anywhere else this might go, or is it exclusive because
we
of
lost you. We lost you. We lost you. You said in general to cap it up, and you dropped out. So can you ask that question again?
I'm sorry. I'm just saying. So it's near field application. That's kind of where we position this stuff.
Near field application. Well, let me. I would like the latitude to qualify my answer. Okay.
Okay.
If you can please grant me the latitude. The most important component in your listening setup is your room. The room is the most important component of your stereo system, and then the speakers. So if your room is properly set up, then you can use an AMT in a floor standing application, not a problem, because you have addressed the combing filter or fixture, whatever the terminology is. The reflection is really a reflection that you've addressed the reflections of boundaries and floor bounce, ceiling bounce. So yes, an AMT works just fine in a floor standing speaker. We've built many speakers, thousands of pairs and floor standings, and many models and bookshelves as well. If that answers your question.
Sure, absolutely. Simon, do you have anything else to quiz Philip on? Give him some tough questions.
No, that is wonderful to hear about. Thanks, Philip.
All right.
Thank you
Okay.
for having me, guys.
Well, let's not flog a dead horse here. Like, it's good to be concise. And thank you, Philip, so much for joining us today. We really appreciate your time. And of course, thanks, Simon, for coming in and adding some technical clarity to everything we do here. So, all right, everybody, if you've got some questions or you want to know more about it, please add some questions in the comments below. And if you like what we do, please subscribe to our channel, the THD. We're doing this every week. So again, thanks everybody, and we look forward to seeing you on the next cast. Thanks, and have a great day. Bye-bye.